Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna.
Hi, Dianna. Happy New Year. We're recording this within that time frame. It's unofficial of that period of time you can say Happy New Year to somebody and not feel odd or whatever.
Yeah, Happy New Year to you too.
That's right. Yeah. And so before we got on the air, we were talking about that. I guess we had both heard of it's that week between Christmas and New Year's, and you're full of cheese and not sure which day it is kind of feeling. I saw that a couple of times and made me laugh.
Me too, yeah.
But we both seem to have the idea that, that's a good time to kind of get organized, to sort out what, clean out stuff and organize things and clean your office and set priorities. And it's not exactly setting a New Year's resolution or anything, but it's in that vein. It's a bit of downtime. The phone's not ringing. Disasters aren't happening, well, hopefully. And you get some time and space to focus on getting organized. And
yeah, we were talking about how that was like that, when we were in the office working. Those downtimes. That it really wasn't that terrible going into the office between the holidays at the end of the year because it was kind of quiet.
It's kind of quiet. The one downside, though, I have to tell you, Dianna, is that you had to make your own coffee. And by the time you got to the end of the coffee pot, it was pretty bad. So,
and you drank more of it than you wanted to. Yeah.
Yeah. Well, there's that. And so it was, but yeah, I look forward to that, and it didn't have to burn, vacation time and all that other stuff. Now I don't much worry about it, but I've kept that habit of this end of the year kind of get organized kind of thing.
Yeah, me too.
Well, and then it brought up the idea is that, putting things in order, sorting things out. And one of them was, the idea was that in a company, wouldn't it be great if we organized, what we were doing? And I think you were talking a little bit about a stage gate review, but that's pretty high level for most, project teams and stuff. It says, at these various stages, here's the major things you need to do. And it's still a pretty good list. But from a reliability point of view, it's, well, when we talk about HALT, this is what we mean in it. And when we talk about accelerated testing, these are the options we have. Here's the types of equipment we typically go after. If you're doing failure analysis, here's a procedure for that, in our organization, that kind of stuff. And there's a lot of value to that.
Yeah, that could be really valuable, especially you're working in an industry or for your company, you have particular products. And it's not that you want to blindly follow the same recipe all the time. But it's not like, it's not going to be all that terribly different. Maybe there's going to be some standard ways of doing things or standard capabilities that you want to be aware of. And just being aware of it, but then maybe also doing a bit of an audit. Is it still relevant?
You're showing your quality side here, Dianna. No, I agree. It's back when I enjoyed the coffee pot to myself era of working in an office. It was one of my roles was to take care of 3 different documents that were used across the corporation. And one of them was a design for reliability manual. And it had a shorthand version of how you do FMEAs. It had the basic structure, the basic steps, and the things to consider, and how do you put a team together, stuff like that, and when and why you'd use it. And it wasn't as comprehensive as Carl Carlson's book on FMEA, yet it was 10 pages, 20 pages. It was enough that if you're familiar with an FMEA, it was the touchstone that's how we do it here.
So it was like your Cliffnotes version.
Yeah. And so it had, I think, 6 or 8, had derating and a handful of other things in it. And we had a separate document for thermal management, and we had a separate document for derating, because each of those then got more complicated and much bigger than what we wanted to put in the guideline. And we had environmental testing was another one. There was actually 4 documents altogether. I didn't do much with the thermal one. There was another team that we got to take over that one. But the idea is that it was a common set of training across the corporation. So it was offered through our office, and we went all over the world, and then we did it online when that became an option for us. And so it was I'd give you the guideline that included, say, the FMEA thing, but we would talk about doing FMEAs for about 2 hours or 3 hours as in more detail and doing an example and do stuff like that. And so it became the language that the company used to do stuff. And the audit part was really the training. So how is it working for you? Where did that? And there was always somebody in the class that was relatively new to the company. Says, well, back at Lockheed Martin, we did it this way. And I says, you're not at Lockheed Martin anymore. I look at him and go, if there's something that would be an improvement, make it more efficient and everything else, and it adds value, let's talk about it. And they go, oh, no, what we did was absolutely worthless. And so like, that's the way we did it. Okay, never mind.
So now this is different than an SOP, a standard operating procedure. Is that right? Because, my medical device background.
Yeah, there you go again.
Yeah, again. Yeah, those kind of details, the companies just decided to wrap it into the quality management system.
Mm-hmm.
So the details on how to do an FMEA and everything were always from the SOP version, but yours was more of engineering application of reliability methods, right?
Right.
Yeah.
And I know medical systems depends on who's regulating it. The audit can be, well, you said you're doing an FMEA. How are you doing that? What are your documentation for how you do this? And I've seen it where it's down to, if you're going to write a test plan, it took 3 weeks and lots of scrutiny and backup because you couldn't modify the test plan as you were going. Otherwise, you had to get the documentation, the plan reapproved kind of thing.
Yep.
The bureaucracy over it was amazing. Whereas I go to the lab with a product and, I'm going to go break it. Well, how are you going to break it? Any way I can. I'm going to increase these relevant stresses. I'm going to do this, that, and the other thing. And talking to somebody in medical systems that is more, got to get it approved, and each step and each duration has got to be detailed. And you're going to take forever to try to learn anything here.
Well, there are different steps, right? There's the R&D, research development testing, where, you can go into the lab and just break stuff. And that was a lot of fun to do that. But then when it came down to the rubber meets the road, like this is our process or this is our design, those test plans and test protocols had to be nailed down and agreed to before those were run. Yeah. But there was a lot of exploratory work that you took notes. You had an engineering notebook. You would take notes on how things were done, and you're in development. So there was still a lot of that. But I think you could have both, like what you're describing with the reliability Cliffnotes for your particular company. Like you could have that separate from your standard SOP. Well, I say that.
Yeah. No, I would keep it out of like, this is how we know that this product is manufactured correctly and safe. Here are the steps. And we would document that much more detailed because we would work with our manufacturing partners to actually implement it.
Yeah, and that'd be part of your file for your product, right?
Right. And we had to be very specific. Otherwise, it just didn't get done well. And I agree, the R&D part, which is where I was focusing and supporting, it was the development teams. And it provided, I got called in one day to one of the divisions, and they were fiercely arguing or agreeing, or, violently agreeing. But they had 6 different ways to do fracas. And and they were arguing which one was better. And there were people from different industries. They had all come together in this one team, but they were from all over the place in the world. Their backgrounds were, no, 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 you do it this way, and you have to have triple documents. And another one's like, no, no, you do it this way, and then you set priorities. And I was like, pick one. You're the boss. Pick one. What's your favorite? Do it. They're all in the end the same, but it's got to work for you. There's no right way to do this. It's
Right.
just it has to work for you.
And
And
that's a problem with big international companies where they have a lot of different types of products.
mhm.
So uh, what you decide to use for your fracas or your FMEA in one division, like your rating scales, your severity
Mhm.
rating scales, might not work for something in another division with a totally different product.
Oh yeah. Yeah,
Yeah.
exactly. And so the guidelines were, and the training that came with it, um, was that sending that message that when there is no such thing as standard reliability tools. I mean, there's typical set of acronyms we use all the time: accelerated life testing, HALT, FMEA, FTA, RBD in the lexicon that we use. But within each of those topics, just FMEA, for example, I think Carl in his book sorted out subtle differences between doing a design or a manufacturing versus a system level versus a software one versus, he had, I don't know, 35 different variations in that book.
Hmm.
And they all are the same basic set of principles, but there's slight variations to accommodate the slight different topic and objective of what you're working on. And that was kind of the gist, is that if you're going to do fracas, the basic idea of this, and for those that don't understand my assembly of badly pronounced letters, is it's failure reporting and corrective action system. Is that what that stands for?
Sure. Yes, I think so.
Okay. Spark of confidence there, I know. But the idea is that don't ignore when something isn't working. It may be very useful for you to understand it and solve it while it's less expensive to do it before it gets to the field. And at some point, you're going to have too many of these things noticed, which is fine. Prioritize them, because you're not going to solve everything. Get over this. Just because you discovered it and you want to work on it, it may not be worth fixing. And have a system to triage this stuff. And it can be done many different ways. And here's what we've just noted as good practice. And that was the guidelines, laid the framework for it. And then each individual team would, whatever reason, they would name their fracas systems different things. One was DDT, one was a bug tracker, and there was a couple other ones that used different variations of pesticides. A bunch of nerdy electrical engineers, I tell you.
And pesticides?
Yeah, they were named after pesticides. Um, like
Hmm.
DDT was like, it's a very bad pesticide. I think it's been banned, like, rightfully, but it
Oh,
was,
yeah. Okay. That's what they
and
named their system after?
yeah, the bug trackers, we're killing bugs.
Oh,
So,
oh.
so
Gosh, that took me too long to make the connection there, Fred. Okay, I get it now. I'm on
yeah.
board.
And so the standard set were things that Dick Muss, my predecessor and mentor, had found through a set of discussions across the corporation, that these were done by teams that did really well, that consistently created reliable products. And they took care of derating. They did stress strength calculations. They did take care of thermal issues. They did FMEAs and did it so that it was useful for them and things like that. And so those were the top few that he noted were consistently being implemented well by the groups that did well in the reliability sphere for their products. And so that's where it came from. It wasn't, Dick or I sitting up there going, oh, you need to do FMEA, you need to do HALT, you need to do this. This was based on this works. And it has proven effect of actually resulting in things. And in different industries, would be a different set of tools.
So it was you were documenting and capturing the best practices.
Mm-hmm.
So in management speak, so you could see the rest of the organization
Mm-hmm.
with those best practices
Yep.
and train on them and have it as a trainable asset that you could
Yep.
use.
And then it, people moved from one division to another on occasion, and now part of it we've found was that you get dropped in a new organization, the FMEA framework principles would be the same. They might do it slightly different because it takes on its own flavor with a different group of people.
Yeah.
Yet the basic structure and ideas and concepts, you put a team together, you do this, that, and the other things, that was consistent because that was what we called it, all our engineers grew up with, this is the way we do things. And we had this structure, this set of standards, basically internal to do that. And part of this, when you first mentioned this topic, I was thinking of like international standards or different various standard bodies that say, here's an FMEA standard, we're doing it that way.
Oh, yeah.
And those tend to be too prescriptive. This is the only way to do it. And I'm like, well, that kind of ruins the concept. You're giving too much details because you can audit those, and you're avoiding the principles which are most important. The concept, the idea, what you're trying to accomplish, gets lost in the details, and then you're just checking the box to
Yeah.
prove that you can demonstrate that you did it. And I think it
That's when they
loses
get
its
really
value.
long too. Yeah. Yeah. I think that's also, it loses their value, like you said, but I think that's when they get really long
Mm-hmm.
too. The grossly oversized FMEAs that are, I don't know, hundreds of pages long.
Oh, I've seen one that was over 1,000 pages. And I said, how many pages of this are you going to read? Well, the top one. Why don't they just send you that?
Even if it's in a database now, that's still a lot for a team to be able to to manage, and that's where I see like these standard prescriptive
Mm-hmm.
methods of FMEA. That's how I see when those things get produced is,
Well,
and I think
yeah.
it's part of the losing the focus of the purpose of why you're trying to do it.
And in talking to the standards body people, it was when we do a document that's shall and should kind of terminology in it, the shalls have to be observable. You have to have a way that it can be checked that it was actually done. And so shalls then created this checklist of documentation or procedural steps and things that an auditor could check. And the idea is that it was hooked to contracts, is that if you're going to do business with us and design this part of the product for us, thou shall use this IEC 87258.2 or whatever the number is. And we're going to check. And it's independent of whether they actually used it well or got any value out of it or made any improvements to the product or not, is did they fill out the form correctly according to clause XYZ. And you're adding shalls to what is otherwise a good textbook. And
Y-
I'm like, just buy the
Yeah.
textbook. Teach people the principles.
Yeah, a better way is, and I think a lot of companies are doing this now, is they're treating their suppliers like, well, they're developing relationships with them
Mm-hmm.
and working with them to develop things and incorporating them and performing FMEAs, which is great. It's a good thing to do.
Yeah. No,
Because then, yeah,
yeah. So the idea of getting a set of standard reliability methods, it has, in my opinion, it has to be what is working for you already. Don't document stuff that nobody knows how to do and nobody wants to do and nobody finds any value in doing. You can spend a whole lot of time documenting some obscure feature of a fault tree analysis that makes it dynamic and you can present a paper someplace on it, but it doesn't do anything for your team, for decision making or anything like that. Document what works, share the best practices, focus on the principles of it, the framework of it, the idea behind it, but not and then turn the dial to 180C and wait 10 minutes. And, you know, no, don't do that. Not for a guideline for best practices.
Yeah, that's too operational.
Right.
So, we talked about beginning of year, end of year, clean out, and I brought up auditing.
Mm-hmm.
Sorry. But was there ever a time when you looked at something and you're like, well, this is out of date, or we don't do this anymore, or we discovered that this different way that we're doing things is better? Was there any point where your group looked at it and said, we're going to leave this behind. We're not going to do this anymore? Or was it always an addition?
It wasn't always an addition. It was, I'll use the derating guideline as an example. It was about every 10 years or so that, and there's new materials being used in components, and there's rarely a new active component. There's different linear regulators, but they're basically a linear regulator.
Yeah, right.
And they might be smaller or something like that. Yet, even with like capacitors getting smaller and smaller, there was different sets of stresses that caused them to fail. Things that when they were large pieces, bending was the big problem. When they're really, really small, it was getting the solder right, and it was different things became challenges over time. And so and it wasn't like the office I was in would rewrite it, but we would lead that program and we'd say, all right, we need representatives, senior electrical engineers from a team across the company to like writing a new standard body, but not as wordsmithing it to death. It was, what are you seeing? What do you need to have as a guideline to help your engineering teams be effective? And so we did, it wasn't quite a survey, it wasn't quite a committee, but a mix of those two things. And then we'd craft the new document, add the new insights and learnings and hints and tips and things like that from these teams, and then send it out for review across the corporation. And it took about 1.5 years to update it.
Oh, okay.
And so things got dropped. We don't use this component anymore. And we could confirm that across the organization. This is just an obsolete component. It's just not even manufactured anymore. We dropped all the mil spec requirements on components because almost no vendor was using mil spec stuff anymore. Mm-hmm. It was, off the shelf stuff was what the military was having to put up with. Tough. You're not the big dog in town anymore. The iPhone is taken over. Yeah. And so it was, and then once that document was done and worked through and cleaned up and published, then the training was updated and we moved on to the next guideline, the DFR manual, and then the next manual. And so it was a regular process of refreshing and updating, and it included dropping stuff that were irrelevant anymore.
So you did this about once a year or so? So there'd always be, well, you said it'd take about 1.5 years to get done, so.
Yeah, and it depended on how complex it was, right? The FMEA one is we updated the example because it was for a product from 20 years ago and it had pretty archaic technology in it. So we updated it. And we added a mass-produced product and a custom high-end, like the supercomputer type product. So it was slightly different example. It'd be in a corporation that's making medical devices, you generally don't talk about infant mortality. And so we, made adjustments because at the time we acquired a bunch of medical products divisions, and I'm like, oh, well, this talking about the bathtub curve, it's kind of, they're making a neonatal care thing. It's probably not a good term for them to adopt.
No.
So we did stuff like that. But we found that if you did an example that was electrical engineering, the mechanical folks would all leave the room and vice versa. So we even did the training separately. We had electrical engineering focused training and we had a mechanical engineering focused training. And it was only derating and stress strength that were different in the two courses.
But they couldn't like hang with each other and like
no. Software
pick up some new skills or something.
No, and software is just never invited. So it was And they were all good with that. It was funny. It was like, shouldn't we talk to those guys? No, they don't like to talk to anybody. I'm like, okay. But anyway,
Mm.
but I think the idea of, you know, determining what's working for you and getting it down on paper so that you have a common touchstone is the way I think of it, is very, very valuable. But going to the manual, textbook and basically copying it out of there and saying, oh, we need to do these 15 things. Well, it's very likely you don't.
Yeah. Yep. Yeah. You have to analyze it. Each analysis has to be specific to whatever you're working on.
Yeah.
Um, and yeah, so having those best practices from the rest of the company and a few relevant examples of what's expected is a good
Mm-hmm.
benchmark. But yeah, you have to create it on your own and talk with your team about it and work with the team to create those analyses to make the right decisions.
That's right. And as soon as you get it published, it's already going to be needing update. So just plan for that. It's got to stay fluid. The principles will be solid. I don't think that will really change over time. The the examples you use, the terminology you use, the types of technology you're using, that will change. And so it's a fun process. Somebody's got to do it. And it gives you a lot of leverage across the organization when you know about a lot of the things that are going on across the corporation. And you can point to the value it creates. So if we apply this best practice, well, we'll get results like the ones that have proven that works for them.
Yeah.
And that adds up pretty quick. But if you've got an idea of your, start of the year kind of updating and cleaning house and sorting and organizing and putting in place type stories related to reliability or quality and all that stuff, let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Dianna and I and the other hosts of the show are available through LinkedIn and our About pages. And I was mentioning to Dianna before we hit record that we were over the holidays, this last part of December, we weren't getting too many questions and comments and stuff like that. So I'm sure you all have plenty of them stacked up, ready to go. So we'd love to see them. So send over your ideas and questions and suggestions for future topics. We always enjoy doing that.
Yeah. Absolutely.
All right. Well, thanks so much, Dianna, and Happy New Year to you again. And which by the time this gets published, we're well outside the zone of being able to say that anymore. So we'll take advantage of what we can.
It's good you preface that. So February or March, people are like, what?
Yeah, that's right.
They're already in the throes of a new project. And
right.
yeah. And the offices are all messy again and nobody's taking vacation. But until then,
it's in the meantime, this will be out there, but not published yet. So we'll see how it goes. Well, thanks so much, Dianna. We'll talk to you again soon.
Okay. Bye.
Bye-bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.